Welcome back, Statistics 1 students. We are on week 17 of maintenance after a few weeks break. The first question for today is again a representation of data question. I think most of these are past exam questions. You can probably find them on the internet somewhere. So we have a traffic camera measuring the speeds, X kilometers per hour. We've got 8 cars traveling along a certain street, and these are our results. So the first thing that we've got to do is find the sum of x minus 62. So what we're going to do is we're going to subtract 62 from each of these values. So this one, first one, 62.7 becomes 0.7 or 0.7. The next one becomes negative 2.4. The next one is 2.2. The next one is negative 0.5. The next one is 6.3. The next one is 4.9, and the next one is 0 because we're subtracting 62, isn't it? Yeah, and so the final one is 0.3. So then I just add all of those together. That's one way of doing it. So another way of doing it, of course, would be to do the sum of x, add them all together, add all all of these together. That's what sum of x means, add all of them together. And then I could take away the 8 lots of 62 that I need to take away. So I could do that. Anyway, either way is going to give me 11.5. Now, the second part of the question is I've got to do the sum of x minus 62. And this is where I think it's easier that I actually worked out each value take away 62. So for this I'm going to go 0.7 squared plus negative 2.4 squared plus 2.2 squared plus negative 0.5 squared plus 6.3 squared plus 4.9 squared plus 0 squared plus 0.3 squared. Now when I did this earlier and chucked it into the calculator, I got 65.13. So far so good. Now the next part of the question is to find the mean and the variance of the speeds of the 8 cars. So for the mean, we can say mean is equal to the sum of x divided by 8. And so I can just sum all of those together, divide by 8. Or I could go the sum of of x minus 62, so this bit here, right? I could do that. I could divide that by 8, and that would give me the mean of the coded data, and then I could add 62 to that, since the whole mean shifts by minus 62 when we code it. So then we add 62 to get to the original mean. Anyway, either way, we should be getting to a mean of 63 I would say 63.4 to 3 significant figures. Now, the variance, remember, since variance measures our spread, and all we're doing is just shifting our data when we do coding with just like a minus or plus. So the variance is going to be the same in both cases. So I can just use the variance, excuse me, I can just use the variance with the coded data. So that will be the sum of x minus 62 squared divided by n, which is 8, minus the coded mean, which is that, squared. Now when I chuck this into my calculator, I'm getting 7.32. And so that's our representation of data question. So let's whip into the next one. So for this one is discrete random variables. So what do we know here? I've got 2 green apples, we've got 2 red apples in the box. Apples are taken from the box one at a time without replacement. When both red apples have been taken, the process stops. The random variable x is the number of apples that have been taken when the process stops. Okay. And I've got to show that the probability that x is equal to 3 is 1/3. Okay, so for it to stop on the third apple, that means we'd have to go something like maybe green apple, then what are we doing? Red? Is it the red ones we're taking? When both red apples, yeah, red, red. Okay, we could do it like that, or perhaps we could go red, green, red, and I think those are the only two ways you can do it, because as soon as you get two reds, you stop. So yeah, so for this one, that would be like taking 1/2 to get your first green, and then to get your first red would be 1/3, because remember the number of apples is reduced to 3 apples. Sorry, that should be 2/3, shouldn't it? Because there's 2 reds and there's 3 apples at that point. And then to get your final one, you'll have 1/2, because there'll be 2 apples, 1 red, 1 green. Okay. Now for this first, for the second example, the first red, you've got a 1/2 chance of picking it. Then when you go for the green, well, there'll be 2 greens and 1 red left, so that will be a 2/3 chance. And then of course you'll have the 1/2 chance and when you pick that final red. So if we add these all together, there I think each 1/6. So altogether we have 1/6 plus 1/6, and so that is equal to 1/3. So there's my attempt at showing that. Now I've got to draw up a probability distribution table for x. Now the smallest number of apples we can take before we get rid of before we get 2 reds, take both of the reds away, is obviously 2. You could go red, red. Then we've got 3, and the most it will take is 4, obviously, because there's only 4 apples. Okay, so what is the probability that x takes a particular value of x? Well, we already know this one here to be 1/3 because we found it out before. Now to get it in 2 goes, it's 1/2 times 1/3, which is 1/6. And you could obviously, probably at this point, you can say, well, this must be 1/2. Okay, and the reason it's 1/2 is because all the probabilities have to add up to 1. Now, if we wanted to prove that this is 1/2 mathematically, well, what are the different ways of doing it? You can go, I guess, green, green, red, red. You can go, what else could you go? I guess you could go green, red, green, red. Or you could go red, green, green, red. I think those are the only options. So green, green. So this would be like 1/2 times 1/3, and then you have to pick. Then it's 1 after that, so you're definitely picking them at that point. So this would be one like that would be one like 1/6 together, wouldn't it? That one. Okay, and this one here would be one. What is it? 1/2 times 2/3 times. Will that be? I guess it's that one 1/2, and then you've got to take it at the next point. So that ends up being, what's that? 2 over 12. So that's 1/6 as well. And then obviously this one's going to be the same, isn't it? So you'll have 1/2 times 2/3 times 1/2, and then you've got to take the red the last time. So this ends up being also 1/6. So you've got 3/6 there, so which is 1/2. So that's the way of proving it mathematically. But I think easiest is just to go 1, take away this, take away this. Okay, that would be easiest. Now moving on to the probability question for today, and we've got another box containing 2 yellow peppers and 5 orange peppers, and 3 peppers are taken at random from the box without replacement, given that, okay, so this is conditional probability, because we've got given at least 2 peppers are orange, we want to find the probability that all 3 peppers are orange. Okay, so we've got to think about the different options here. So you could go yellow, orange, orange, yo. Or you could go orange, yellow, orange, yo. Or you could go orange, orange, yellow, ooh. Or you could go orange, 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 ooh. Okay, so those are our different options. I don't know, I feel like I'm in a silly mood today. So the first one is 2/7, right? Because there's 2 yellow peppers, and then you times that by 5/6, and then by 4/5, because each time you're reducing the number of peppers. So what is this? 4/21, 4/21. This next one here, orange. Again, we start off with 5, and there's 7 peppers. And then if we go for a yellow, we've got 2 of them and 6 peppers left. And then we go for our next orange, which is like, what is that, 4, isn't it? 4/5. And so this is giving us 4/21. And you can see that this next one will also be like that. So you're going to have orange is 5/7, and then you'll get 4/6. Then you'll get the 2 for the yellow, 2 out of 5, and there's also 4/21. The last one is triple orange, so it goes 5/7 times 4/6 times 3/5, and that gives us a total of 2/7. Now you might be thinking, why the blazes has he done this? Okay, well, because we're taking 3 peppers, and we know that we've got at least 2 of the peppers are orange. So these are all the ways you can have 2 peppers orange, or 2 or more peppers orange. Okay, right. Now the question says, given that at least 2 of the peppers are orange, find the probability that all 3 are orange. So I'm going to say 3 orange given greater than or equal to 2 orange. Okay, I don't know if that's definitely not a very good way of writing it, but just to think about it, that's what I'm doing. And so I could say this means the probability that the intersection of those 2, which is all 3 are orange. So that's how both of them happen together, divided by the probability that at least 2 are orange. Okay, so this is simply going to be, well, this last bit here, 2/7, and then we sum all of this together. So what's that? We can turn it all into 21sts, I guess. So 2/7 is like 6 over 21, isn't it? And then we've got 6 and 4 is 10. 4 is 14, 18, so I think it's 18 over 21. And when we simplify that down, we're going to get, what was that? 1/3, I think. Yeah, 1/3. Okie dokie. Now moving on to our favourite, permutations and combinations. So we've got 7 fair dice, each with the faces. These are the faces, 1, 2, 3, 4, 5, 6. Thrown and placed in a line, find the number of possible arrangements where the sum of the numbers at each end of the line add up to 4. Okay, well, if you're thinking about your dice, how can you do this? Well, you could have a 1 and a 3 at each end, or you could have, and I guess the opposite of that would be, you could also reverse that, couldn't you? So you could have a 3 and a 1, right? So just you can have them reversed. You could have a 2 and a 2. Obviously there's no reverse there. And I think that's probably it. Yes. Okay, so let's consider this here. So to represent the fact that I can switch it around, I'm going to times everything by 2. And then I'm going to go, what am I going to do at this point? Okay, the number of possible arrangements where the sum of the numbers at each end. Okay, so in between, so I've got 7 fair dice. So in the middle here, right, 1, 2, 3, 4, 5. In the middle there, each of those dice is going to have 6 different options, isn't it? So for instance, for this one here, you've got 6 options. For this one here, you've got 6 options. So it's 6 times 6, and this one's got 6 times 6 times 6 times 6. So I think it should be 2 times 6 to the power of 5. Okay, and then and there's 2 of them, and then this last one here would be 6 to the power of 5 as well. So altogether, you could say 3 times 6 to the power of 5, I think, would be the answer here. All right, let's move on. I think that's fine. Find the number of ways in which 9 different computer games can be shared between Waina, Jingyi, and Hibi. Okay, so that each person receives an odd number of computer games. Okay, so let's write the names out here: W, J, and H, and if they have odd numbers. Okay, so let's have a look. We can have 3, 3, 3. That's one way of doing it. I guess we could have 1, 3, 5, and therefore we could have 1, 5, 3, and we could have 3, 1, 5. And I guess, what's the other one? 3, 5, 1. Yeah, is there anything else? No, I don't think there's another way. I think that's it. Otherwise, you'd end up with someone not having any... hang on. No, there are more. No, there's not much room. I'll just do another column here. Okay. Yeah, so we could do... Yeah, we could start this dude with the 5. So we could go 5, 1, 3, 5, 3, 1. And then we could do 7s, couldn't we? So we could go 1, 1, 7, 1, 7, 1, and 7, 1, 1. So I think that's all of the different options there. It gets a bit complicated, doesn't it? Okay. Okay, let's mark this out. So this one here is the relatively simplest part. So for this one, what I'm going to do is I'm going to go, I've got 9, choose 3, so that's for W. And then the next one, I've got 6 left, and that's for J. And we're gonna get 3 for him, 6, choose 3. And then obviously the last dude just gets what's left over. So that's the yellow part. Now let's think about this red part from here, here. So it's all the same combination of numbers just mixed around, isn't it? There's just 6 different ways of arranging 3 numbers, isn't there? Like 3 factorial is 6. So what about this section? What do we do? So, okay, obviously we've got that 3 factorial because there's 3 ways of arranging it. Now let's just look at one of those ways. So why don't we focus on this way here? Okay, so that would be 9, choose 1 for that first Larry, for W, and then the next one gets I guess times 8, choose 3, and let's see what we get with that. 8, choose. Yep, I think we're on the right track here. And then this last bit here, see there's 3 different ways of arranging things here. So I'm going to put that as a 3 to start off with, 3 times. And I could go, there's really 2 ways of doing it. Let's just start at this level. So I'm going to go 9, choose 1. So W gets 1 out of 9. And then there's 8 left, and the second dude gets 8, choose 1, and the last dude gets everything else. Now, if we add all of these things together, right, this plus this plus this, we get, now I'm getting 4,920. Well, that's what I did when I did it. Okay, hopefully that's right. Hopefully I didn't make a mistake on that. Now, the last one is discrete random variables, the binomial distribution. So this is a relatively new topic for us, but good to review it. So the number of books read by members of a book club each year has a binomial distribution over this. State the greatest number of books that could be read by a member of the book club in a particular year, and find the probability that a member reads this number of books. Well, the greatest number is 12. That's what this bit here represents, 12. Now the probability that someone reads that, what is the probability that equals 12 is going to be 12 choose 12 times, now the 0.7, remember, is the probability of success, 0.7 to the power of 12, and then the probability of not doing that is 0.3 to the power, and he's got to read every single one, so that will be to the power of 0. So we just pop this into the old calculator. This should give us a 0.0138. Find the probability that a member reads fewer than 10 books in a particular year. Now, the easy way of doing this is we're going to say 1, take away the probabilities of x equals 10, 11, or 12. Now, I've already found 12, so we're going to go 1 minus the probability, and I'll put this in brackets, of x equals 10. So that would be 12 books choose 10 times the probability of reading 10 would be 0.7 to the power of 10, and therefore 0.3, which is failure, probability of failure for 2. And then the probability of success for 11, 12 choose 11 times 0.7 to the power of 11 times 0.3 for 1, so a fail for 1. And then we can take the value that we had here, which was 0.0138. You probably want to take your unrounded number, but I've just rounded it here. Okay, and then we chuck this into our calculator, and we should get our final answer. Now, the answer I'm getting for this is 0.747. Well, that brings us to the end of another week of maintenance. I hope this has been helpful. I hope I didn't rush too much in some of the more tricky ones. If you do have any questions, please let me know. God bless, guys.